September 11th, 2025. The world slept in silence. But high above that silence, something extraordinary stirred. Not in a billion-dollar observatory, not through the world's largest telescopes, but in the dim glow of a small apartment in Ukraine, where a lone amateur astronomer stared at his aging laptop. And what he saw would ignite a story of brilliance, mystery, and cosmic rivalry unlike anything the modern sky had revealed. Because that night, a single faint blur appeared against the black canvas of space, and within hours it exploded into a spectacle brighter than 10,000 power stations, unfurling a tail so vast it dwarfed the size of 5 full moons side by side. This was Comet Swan, a celestial engine blazing with unnatural fury, a discovery that defied the machines and reminded us that sometimes it takes human eyes to see what technology overlooks. But what Swan revealed was only the beginning. For another traveler, Comet Atlas, was already racing toward the inner solar system, an interstellar visitor on a collision course with Mars. And between them, a mystery began to unfold. Vladimir Bezugi, the amateur astronomer who first noticed Swan, was no stranger to sleepless nights. While professionals trusted their robotic surveys, he relied on persistence, instinct, and the flicker of hydrogen emission maps scrolling across his battered laptop. That night, just after midnight, a smudge appeared. Too subtle at first, almost like a ghost between the stars, but with every frame, the blur sharpened. A blue-green plume stretched outward, spreading with a speed he had never seen before. He knew instantly this was no glitch. Within minutes, he ran his custom scripts, flagged the anomaly, and sent it racing across the internet to Comet watch lists, mailing groups, and amateur channels. By dawn, the world's largest observatories were already turning their lenses toward the coordinates he had given. And there it was, Swan. A comet 400 times brighter than Atlas, 200 times larger in the sky, visible to anyone with nothing more than a pair of binoculars. But the question whispered louder than the spectacle. How could every professional survey miss something so obvious? And if Swan had been overlooked, what else was the universe hiding? At the same time, Comet Atlas cut across the solar system like a phantom blade. It wasn't born here. Its orbit was hyperbolic in exile from interstellar space, never to return. It raced inward at 58 kilometers per second, crossing the distance between New York and London in less than 2 minutes. Unlike Swan, Atlas was faint, a magnitude buried in darkness. Yet when the European Southern Observatory captured its spectrum, a shock emerged. Atlas carried an alien fingerprint. Its coma glowed with carbon dioxide at an 8-to-1 ratio over water vapor. Even stranger nickel vapor, and unexpected drifted through its faint cloud. This wasn't just a comet. It was a sealed container of chemistry forged under alien suns, a messenger from beyond. But just as Atlas revealed its secrets, Swan began to overshadow it, burning brighter, closer, and fiercer. The rivalry of two cosmic wanderers was set. One brilliant but native, the other faint but alien. And both were heading toward their most dangerous moment, perihelion, silence. Both comets slipped behind the sun, disappearing into the glare where no telescope on Earth could follow. For 11 days, the universe went dark. Its Swan fragmented, if Atlas erupted, if their tails tore apart under solar fire, no one would know. The blackout came at the worst possible time, just as Swan approached Earth, just as Atlas neared its peak. All astronomers could do was wait, argue, and simulate. Data turned into whispers of probability. Monte Carlo simulations filled servers with tens of thousands of possible outcomes, but the truth remained locked behind the sun's blinding curtain. Would Swan survive? Would Atlas? Or would both vanish, leaving only silence where brilliance had burned? Even Swan's orbit became a source of tension. At the Minor Planet Center, early calculations suggested a return time of just 1,400 years. A comet humanity might see again within history. But at NASA's JPL, working from slightly different data, the answer stretched to nearly 20,000 years. 19,000 years of disagreement, not rivalry, not failure. But the edge of science itself, where the unknown refuses to give way,